There is a place deep in the ocean where pressure is 1,000 times stronger than that we're used to at the surface. This force is enough to turn an unprotected human into dust instantly. Well, maybe more like mud. Anyway, that's why explorers need some serious preparation and equipment to survive in such extreme conditions down in the Mariana Trench. It is as wide as 20 national malls in Washington, D.C., and about 1/5 as long as the diameter of Earth. People who went all the way down describe it as a chilly, quiet, and very peaceful place. They saw a bright blanket of red and yellow rocky outcrops, and there was a whole variety of unique, small, translucent animals. The popular myth is that more people have gone to the moon than to this deepest place on Earth is not true, though. In total, 24 humans flew to the moon, and at least 27 brave souls dove down to the Mariana Trench. Most of them were explorers and not proper scientists. They just go there for the thrills and also to collect video evidence of different wildlife, geological formations, and human-made objects. Humans started traveling around space and into the ocean depths at around the same time. The first moon landing was in 1969. And the first person to go down the Challenger Deep, the deepest part of the Mariana Trench, did so in 1960. This unusual location got its name after the British ship HMS Challenger, which first located this massive drop in the ocean floor at the end of the 19th century. It would take 8 more decades before the first human went down to it. Explorers didn't manage to do it in a conventional submarine. They used a type of submersible called a bathyscaphe. The Swiss oceanographer Auguste Piccard designed his own in 1953. 7 years later, the submersible managed to do the impossible. It had reached a depth of nearly 36,000 feet. But what explorers saw was merely a fraction of the trench's full size. The fact that it is so huge of the Mariana Trench is just one of the reasons why it's mostly unexplored today. The absence of light is another major issue. Sunlight is incapable of reaching such profound depths, so the entire trench from top to bottom lies in absolute darkness. Because of such conditions, the ecosystem is a lot different than the shallower regions of the Pacific. This puts immense pressure on marine wildlife. Yeah, the pun is intended. Another reason why it's so challenging to survive there is the temperature. Water freezes at 32 degrees Fahrenheit. At the bottom of the Mariana Trench, the ocean is just a couple of degrees above freezing. One of the factors that hasn't let this area turn into a giant icicle is the fact that salt water has a slightly lower freezing point. The other reason is geothermal energy that warms the ground at the bottom of these just enough for it not to freeze. That's why submersibles need to have proper insulation to navigate these icy conditions. When they reach the bottom, researchers find out that this desolate and harsh climate is home to several animal species. They encountered arrow-toothed eels, snailfish, and spoonworms at various depths. There were even strange-looking translucent sea cucumbers and shrimp-like amphipods. The biggest surprise was microbial mats thriving on methane and hydrogen from the mud. Among the species, the Mariana snailfish looks like a master of the environment that can go farther and deeper into the trench to feed on prey than its competitors. Despite its seemingly fragile appearance, the snailfish has adapted to withstand extreme pressures, a superpower it wouldn't be able to survive without. The exotic life forms that live deep down aren't normal-sized, since deep-sea gigantism makes them grow significantly larger than their counterparts in other ecosystems. One example is the giant tube worm, which can be 6 feet long. Science has a hard time explaining the exact cause of this form of gigantism. Thermal vents are just one of the possible explanations. All of these factors might help explain the huge time gap in researching the Mariana Trench. The first successful dive after the 1960 expedition came only in 2012. That's when the famous Canadian film director James Cameron went down in the deep-sea Challenger. Because few scientists have gone that deep before or after Cameron, There is no map of the deepest point on our planet. We know very little about the oceans that cover 2/3 of the Earth's surface. Researchers have mapped out only 5% of them so far. Science still has a lot to discover in the Mariana Trench and other unexplored places on our planet. The Amazon rainforest stands as the best example of the world's most unexplored regions. The list of reasons why this part of South America is unknown starts with its wildlife: jaguars, anacondas, piranhas, black caimans, and Brazilian wandering spiders are just some of the creatures that pose a risk for researchers. Relentless year-round rainfall induces heavy flooding. Add to all this some treacherous river currents, and you can see why scientists have mapped such a small percentage of the Amazon to date. In just one region of Brazil, near Peru, there are at least 14 tribes that have never had contact with the outside world. The national authorities intend to keep it that way. Isolation of these indigenous people is the best way to protect their future. The same goes for a remote island in the Indian Ocean. After the tragic tsunami of 2004, helicopters flew over North Sentinel Island to make sure its inhabitants were alive and well. Meanwhile, the Sentinelese weren't thrilled. They took up bows and arrows to drive away the unwanted visitors. This tribe is one of the last uncontacted tribes on Earth. Although anthropologists and filmmakers visited the island in the late 1960s, we still don't know much about its indigenous population. It sits a long way off any shipping lanes in the Bay of Bengal. North Sentinel has no natural harbor, and it's surrounded by a shallow reef. This makes access to the island possible only by boat. The Indian officials who lay claim to the island have prohibited outsiders from visiting the island for safety reasons. The estimates on how many people inhabit the island vary significantly, from as few as 15 to as many as 500. The island is not tiny. It's about 5 times as big as London's Heathrow Airport. Apart from occasional contact during the past 2 centuries, the Sentinelese must have been isolated for a long time. They are related to other indigenous groups in the Andaman Islands, but their neighbors cannot understand a word of their language. The continent of Antarctica has no permanent human settlements at all. The only people who periodically live there are international scientists. This vast expanse of ice and snow, roughly the size of the United States and Mexico combined, still has many regions where humans haven't set foot. Satellite imagery and photos that NASA's aircraft made from the air have mapped out the entire continent. So we know where to go, but it's not that easy. The reason for this are all the adjectives that go with Antarctica. It is the coldest, windiest, driest, and brightest of the 7 continents. This makes it virtually unlivable. More than 99% of its surface is covered with a permanent sheet of ice. Its thickness ranges from 1 mile to as many as 3 miles in some places. That's half the height of Mount Everest. Now, the Himalayan range contains the world's tallest unclimbed mountain. It is also the tallest mountain in Bhutan. In the local language, the mountain's name translates as White Peak of the 3 spiritual brothers. Out of respect for the spiritual beliefs of the local population, national authorities restricted and then completely banned mountaineering at the beginning of the 21st century. To this day, there is no evidence that any climber has ever managed to successfully reach the summit of this mysterious mountain.
It's one of the most intriguing locations in the world. Covered in darkness and miles underwater, this extreme environment is home to some unusual creatures and phenomena. It's called the Mariana Trench, and it's the deepest oceanic trench on Earth. No wonder it's been so difficult to explore. Because of the risky conditions, people aren't able to explore this location without proper equipment. But what would happen if we threw a steel ball down there? Let's start with some basics. How did they first discover this enormously deep hole in the ocean? HMS Challenger identified it back in 1875. The ship had some pretty fancy sounding equipment for its time, but it wasn't nearly good enough to be able to fully explore the trench. Some decades later, in 1951, another ship, The HMS Challenger 2 came back to the location better equipped. The vessel featured an echo sounder and was able to take accurate measurements of what seemed to be the deepest point on the surface of our planet. If you were to look at it in 2D, you'd see the trench measures 1,500 miles in length and 43 miles in width on average. It also looks sort of like a crescent-shaped scar when you observe it from above. Nothing out of the ordinary so far, right? Well, if you were to stretch a wire from the surface of the ocean to the trench's deepest point, it would measure a staggering 7 miles. If we were able to physically move Mount Everest, which is the Earth's tallest mountain, to cover the Mariana Trench, it still wouldn't be enough, falling short by about a mile. Because the Mariana Trench is so deep, it's almost completely covered in darkness, as light can barely get through to such extreme distances underwater. The temperature isn't any friendlier either, just a few degrees above freezing. But the most dangerous feature of them all is the water pressure. Right at the deepest point of the trench, the amount of pressure is about 1,000 times higher than the standard atmospheric pressure. Not a lot of people ever attempted to descend into the Mariana Trench. In fact, the first organized attempt took place more than 60 years ago. It was done by Jacques Piccard and Don Walsh in a submersible. They only spent about 5 hours on their descent and a mere 20 minutes at the bottom. Alas, they weren't able to take any pictures. Until these two scientists were able to descend, specialists believed there was little to no chance that life could exist down there, given the conditions, most notably the extreme pressure. But while at the bottom, the submersible's floodlight caught sight of a creature. It was a very flat one indeed. As you can imagine, resources here are very scarce. What kind of creatures live down here? And how do they survive, given the harsh environment? Surprisingly, there is quite an abundance of wildlife living in the Mariana Trench. Some of these creatures fall back on chemicals to survive, like methane or sulfur, while other kinds of fish nibble at the marine life that's, well, weaker than them on the food chain. The most common creatures found here are xenophyophores, amphipods, and small sea cucumbers. Some of them adapted by hardening up their shell using aluminum harnessed from the seawater. Smaller creatures, like microbes, adapted by feeding on the chemicals emitted when the seawater hits the underwater rocks. They consider the Mariana snailfish the rock star of the area in terms of wildlife. They're small, ranging from 3 to 9 inches, translucent, and lacking any scales. But they're the top beast of prey in the area. It's no wonder some people started to believe that the ancient Megalodon might still be living here. What was a Megalodon, you might be wondering? It was the largest predator ever known in our planet's history. Basically, the biggest and nastiest shark ever to have lived. Scientists believe it's been extinct for quite some time, and the idea that it might still be hiding in the Mariana Trench doesn't have a lot of supporting information. The Megalodon would have needed to learn to navigate in complete darkness. It would either have to be bioluminescent or evolve to have massive eyes. More so, because of its school bus-like size, the Megalodon would have needed a lot to eat. Microbes and small snailfish just wouldn't have done the trick. If a steel ball were to be dropped in the trench, what would be its effect on it? Would the ball be strong enough to sustain such pressure? Let's look at the science here. If we assume it's a solid steel ball, the pressure found at the bottom of the trench wouldn't be enough to really affect it and cause permanent damage. It would take it a solid 12 minutes to reach the bottom of the ocean, though. What about the temperature? Well, it turns out that the difference in temperature on the surface and at the bottom of the trench is quite impressive, a difference of about 86 degrees Fahrenheit. So, it would cause the ball to shrink a bit, but yet again, once the ball returns to the surface, it would simply come back to normal. Should the ball get stuck there, there's another interesting question to answer. Would corrosion affect it? Corrosion of steel is highly dependent on the amount of oxygen in the water. The amount of oxygen dissolved in water remains constant at depths greater than 3 miles. I'll spare you the math, but it would take more than 10,000 years for the steel ball to completely rust under the sea. I can't help but wonder though, what would it take us humans to be able to survive at such extreme depths? Let's look at what was used in the past to explore this mysterious location. A little thing called syntactic foam. Why? Because it's the only material that can both float and resist the amount of pressure found here. Without this sort of protection, our lungs would rapidly collapse here. More so, the pressure from the water would push liquid into our mouths, replacing the much-needed oxygen with water. Then, there would be the much-needed ability to be able to come back to the surface, should anything not go as planned. One of the vessels that went for a deep dive here had 1,000-pound steel weights attached to it, so it would ensure its sinkage. These weights were connected to the ship by a special type of wire that had an increased corroding time of 11 to 13 hours in seawater, just in case something went wrong down there, and they'd have to bounce back faster. Given the harsh conditions here, the problem of oxygen supply is really important too. Any vessel looking to descend into the Mariana Trench again would need to consider some sort of device that can recycle the air in order to reduce the amount of oxygen that needs to be transported down there. And the last, but definitely not the least of all problems, would be electricity. There surely isn't a power socket down there for you to charge your phone. So, there needs to be enough battery life to support all the necessary equipment, communication, oxygen supply, lighting devices, and so on. None of these problems seem to be quite the challenge anymore, since, as of recently, you can buy a tour of the Mariana Trench. 3 lucky individuals were part of such a project back in 2020. They were submerged in a 3.5-inch thick titanium sphere. This ensured that they didn't feel any pressure changes and physiological stresses whatsoever. Each of the guests took part in an individual trip that had an estimated length of about 14 hours. The descent itself took over 4 hours. Once they reached the bottom, they got the chance to witness some of the most extraordinary creatures on the planet. Then it was time to start the 4-hour ascent back to the surface.
Can you swim? Good. Because you're going on a journey to the deepest point of the Pacific Ocean. Now, put on your flippers. The very bottom of the Mariana Trench is awaiting. Now, get in the water. Really, come on. All right. 1 foot underwater. That's the depth you can swim with no special gear like a mask. Hey look, must be some tourists. Or whales. 10 feet underwater. That's a little deeper than the public pools and beaches around the United States. You can see colorful fish and even phytoplankton that feed on the sun's rays. 26 feet down. This is the depth at which the foundations of the floating city of Venice in Italy stand. Builders laid columns at that depth on which they later built houses and streets. 30 feet underwater. You start to feel a lot of pressure. When you're on the surface, you're under atmospheric pressure, 15 pounds per square inch. But here, at 30 feet, that pressure is doubled. All the air pockets in your body, like your lungs or ears, begin to compress from this pressure, giving you discomfort. But no worries, your organs are soft and elastic, so you can keep diving. 40 feet underwater. Oops, you're running out of air. An average person can hold their breath for 30 to 90 seconds. The current record is an incredible 24 minutes and 37 seconds. Gasp. Okay, you'll need some diving equipment to continue your descent. There you go. Thank you very much. Tourists dive to this depth to look at reefs and corals. You don't need special skills for that, but you can't dive any deeper without training or a license. 45 feet down. Be careful. There's sharks swimming here looking for food, like you. Sometimes tourists descend to this depth in a safe cage to see the sharks up close. You're better off staying away from these predators and not attracting their attention. So make sure you're not wearing any bright and shiny jewelry. Sharks love that kind of thing. 62 feet underwater. You could see the Aquarius Reef Base Lab in Florida at this depth, if you were in Florida. It's really an entire building with rooms for exploring the seafloor, accessible through a hatch. 105 feet down. You see a strange bell hanging from a chain. People used to use these things for deep diving about 400 years ago. They'd lower a bell on chains with divers inside from a ship. There was enough air inside the bell for them to breathe. That way, they could explore sunken ships with treasures. 140 feet. At this depth, you could find an entire sunken city in Qianda Lake, China. You can still see streets, houses, and temples there. 330 feet. Whoa! You almost hit a huge blue whale. How could you miss it? These guys, the size of 2 train cars, usually dive to that depth. Shh! Let's listen to them sing for a while. It's beautiful. Now, let's keep going. 660 feet. This is where most of the ocean life ends. Sun rays hardly penetrate any deeper into the water. Everything below are unusual fish like this angler. They have such an unusual appearance because they have to adapt to the high pressure here. 702 feet underwater. This is the last mark where you'd see a human without diving equipment. This man holds the title of the deepest man on Earth, and he's the only one who has managed to get to this depth. The water pressure on his body here was 20 times greater than that on the surface. 985 feet. Ooh, what was that sound? Whoa, that's a submarine. That's the maximum depth they can dive to. Some of them can reach speeds of 26 miles per hour. Fun fact, an ostrich can run twice as fast, but she can't swim. 1,090 feet. Say bye to this scuba diver. You won't see them any deeper than this. The world record was set in the Red Sea. It only took the diver 12 minutes to reach this depth, but it took him a whole 15 hours to return to the surface to avoid decompression sickness. So now you get an atmospheric deep diving suit. It's completely sealed, and you won't feel the insane water pressure on your body in it. 1,454 feet. If you stuck the Empire State Building in the water, its tip would be here, and all the carpet inside of it would be wet. 2,300 feet down. The water pressure here is 70 times greater than on the surface. The flexible plastic parts of your suit can't withstand that kind of pressure. So here's some urgent delivery. It's an ultra-deep submersible. Now you can continue your dive all the way down. 2,717 feet. Here you'd see the tip of the tallest building on Earth, the Burj Khalifa. Alright, who's sinking all the tall buildings around here? 5,387 feet. This is the depth of one of the oldest and deepest lakes in the world, Lake Baikal. Its area is slightly larger than the entire country of Belgium. 8,040 feet. That's the record depth the Perdido oil platform reaches in the Gulf of Mexico, and its above-water part with 3 decks is almost as high as the Eiffel Tower. 11,962 feet. This is the average depth of the Atlantic Ocean. You can see a huge tube as wide as a giraffe's neck, and it just seems to be endless. True, this cable connected Europe and North America and used to serve for telegraph communications. 12,303 feet underwater. Suddenly, in the darkness, you see the outline of a ship. No way! That's the Titanic itself. The intense water pressure would crush a person at this depth, so you can only dive down to the Titanic in a submarine. 13,123 feet. Whoa! Here would be the end of the deepest mine in the world, Imponen Gold Mine in Africa. But you still have deeper places to go. Let's speed up. 20,000 feet. Here you can see the deepest debris of an old ship. The USS Johnson sank more than 70 years ago. You can still clearly see the number 557 on its bow. 26,200 feet. Here, in this total darkness, you'll find the deepest fish in the world, the Mariana snailfish. They're as long as a domestic kitten and have almost transparent skin. Their eyes are poorly developed for vision because the sunlight never reaches this deep. 29,030 feet. If you take Mount Everest, flip it over, and stick it into the Mariana Trench, this is exactly where you'd see its tip. Even though this is the highest point on our planet, you'd still have a lot deeper to go. 35,755 feet down. Here, in the Challenger Deep, you'd still see life. You'd need a microscope for that, though. Bacteria living here feed on organic molecules, similar to oil. A little deeper? Congrats! You've touched the bottom. It's 36,070 feet deep. The pressure here is 1,071 times higher than on the surface, But you're not the first person to have been here. One of the last expeditions to the bottom of the Mariana Trench was in 2012. An American filmmaker descended here in a submarine he designed himself. But the pressure broke some of the engines, so it was hard for him to maneuver here. The sonar was also damaged, and some of the batteries drained. He was in the Challenger Deep for about 3 hours and took many pictures and videos. If you look closely at the bottom itself, you can see bubbles. It's carbon dioxide and liquid sulfur. It's freezing here because of the extreme pressure and temperature close to freezing. But there's still life here in these harsh conditions. The 3 microorganisms are most common here: xenophytophores, amphipods, and small sea cucumbers. There's so few of them because they don't have enough food down here. Usually, there's a lot of palm leaves on the ocean floor, which get there from the land. But the Mariana Trench is 124 miles from the nearest islands. So the only food here is old plankton and fish scales from the ocean's upper layers. But it needs to travel tens of thousands of feet to become food for the bottom dwellers. But can you go even lower into the crust of the Earth? Well then, you'll need to unleash your giant drill and fire up the jet engines. You're pushing another 36 miles through the Earth's crust, and here is its edge. You've entered the upper mantle. It's an ocean of hot lava, 1,800 miles deep. You have to literally swim through this, reaching the outer core, another 1,400 miles deep. Then you reach the inner core, another 755 miles, and congrats! You're at the very center of the Earth. I hate to ask, but how do we get out of here? Now, the Mariana Trench is the deepest and probably the most enigmatic place on Earth, whatever that means. Bizarre creatures, such as deep-sea anglerfish, frilled and goblin sharks, barrel-eyed fish, hatchetfish, live in a crescent-shaped trench in the western Pacific. Just 3 people have ever descended down the Challenger Deep in the southern end of the Mariana Trench. There, at a depth of almost 11,000 feet, vents are bubbling up carbon dioxide and liquid sulfur. Mud volcanoes erupt under the pressure 1,000 times greater than at the surface. And so, it's no place I want to go. So bye!
Get back in there.
Alright, since you clicked, yeah, you're about to visit places no less mysterious and creepy than the Mariana Trench. Your first stop is Mexico, the Yucatan Peninsula to be precise. See those bottomless sinkholes filled with crystal clear water? It's fresh water that overlies salt water seeping from the sea. The sinkholes are called cenotes. The Mayans believe these natural wells were the gateways to the underworld. Thousands of cenotes, created by collapsed limestone bedrock, form one of the world's longest underwater cave systems. You can easily get lost in this tangled, mysterious network. Now it's time to visit the Caribbean. There, you'll get to a depth of almost 8,000 feet to see the Van Dam vent field. The hydrothermal vents fire out streams of muddy, scalding water, with a temperature reaching 400 degrees Fahrenheit. That's almost enough to bake a pizza. These mounds are made of talc, a substance you can find in baby powder. The Van Dam vent field is an oasis for odd species. One of those is kind of a creepy shrimp without eyes. Instead, they're equipped with patches of light-sensitive cells on their backs. Now, you don't have to travel far away. The next enigma on your list is also in the Caribbean. Just off the coast of Belize, there is a giant sinkhole. It's also blue. Yep, that's the Great Blue Hole. The thing is about 1,000 feet across and more than 400 feet deep. Once, a long time ago, this hole was a cave until rising waters filled it, making it collapse in on itself. The deeper you descend into the Great Hole's crystalline waters, the darker it becomes. You see tons of stalactite-filled caves, but don't even try to enter them unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you notice the water shimmer. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. Time to get out of there. Who knows what you might come across in the murky depths? Your next destination is off the Pacific Northwest coast. Almost 500 streams of methane bubbles were discovered there several years ago. Because of the bubbles, the vents got the name Champagne Seeps. which sounds better than the fart spas. Scientists are still puzzling over this phenomenon. Where does the methane come from? Underwater cows? Why is its temperature warmer than that of the surrounding ocean? And most importantly, what would happen if you managed to light a match somewhere near a large bubble? Methane is a highly flammable gas, and setting a methane bubble on fire, well, you get the picture. And now you're off to Iceland. The plan is to dive into Silfra, a fissure filled with pure glacier water. This 206-foot deep crack is the only underwater place on the planet where you can touch 2 continents at once. The deeper you go, the darker it becomes. The rocky landscape looks otherworldly. Divers who dare to visit this incredible place risk having their gear frozen, getting hypothermia, or not surviving whatsoever. After all, the water temperature in Silfra Fissure is about 35 degrees Fahrenheit year-round. Your next destination is Scotland. Okay, cue the bagpipes. If you dive in the Gulf of Corryvreckan, a narrow strait between 2 islands, you'll see massive underwater rocks and deep holes. They create the 3rd largest permanent whirlpool on the planet, the Corryvreckan Maelstrom. The water moves through the strait at breakneck speed. It hits the underwater rocks, and the place looks like a pot with boiling water. The waves created in the process sometimes reach a height of 15 feet, and you can still hear the roaring whirlpool from 10 miles away. It's believed the Corryvreckan Maelstrom has swallowed dozens of sailors over the centuries. They were caught unaware by the ferocity of this natural phenomenon and pulled underwater in the blink of an eye. Okay, enough bagpipes. Your adventures are getting more and more extreme. You're heading for Antarctica. There, in the Southern Ocean, you'll find the Ross Sea Ice Shelf. Say that 5 times real fast. Later, not now. It's roughly the size of Spain, with the ocean underneath containing as much water as the North Sea. Once, scientists drilled all the way down through this enormous chunk of ice. Imagine their astonishment when they found life in those extreme conditions. The researchers came across dozens of mysterious species not known before. The most unnerving were upside-down swimming fish and overturned sea anemones hanging in the frigid waters. Hopefully, bizarre places with a notorious reputation don't frighten you. Well, too bad, because you're about to visit the Bermuda Triangle. It's an area between Bermuda, Florida, and Puerto Rico where planes and ships seem to vanish in thin air. For the first time, this place attracted a lot of attention in 1945. That's when 5 U.S. Navy planes disappeared during training. Before radio contact was lost, the flight leader said, "We're entering white water. Nothing seems right." After that, the planes with 14 men flying them disappeared. Even scarier, a rescue plane with 13 people on board never came back as well. Some people believe the mythical city of Atlantis lies at the bottom of the triangle. They claim its inhabitants use extraterrestrial technologies to sink ships and crash airplanes. Others blame rare and unexplored natural phenomena, for example magnetic anomalies, or massive pockets of flammable methane gas. There we go again. Then, if a bolt of lightning ignited a giant methane bubble near a ship or a plane, this could probably make it sink without a trace, except the smell. But methane is found everywhere all over the world, and it never behaves this way. Some experts aren't sure there's a mystery to explain whatsoever. Lots of busy routes pass through this area. No wonder more ships and planes sink there than anywhere else. Now, prepare some warm clothes. You're heading for the north again. Your destination is Cape Desolation in Greenland. Nice place. In 2012, Canadian researchers were sampling the water in that area, and their equipment came back to the surface with pieces of coral attached to it. That's how a cold water coral reef was stumbled across. These unique pinkish corals can easily go without sunlight and live in strong currents 3,000 feet below the surface. Another unique spot you can't miss lies between Greenland and Siberia. The Gakkel Ridge is the deepest and most remote portion of the global mid-ocean ridge system. In some places, it reaches the depth of more than 3 miles. It's only natural the darkest corners of this underwater world remain unexplored. Fascinating chemical reactions happening at the bottom of the ridge produce hot fluids rich in minerals. They spew, like freshmen at a rush party, from seafloor vents. And since these vents are isolated from the rest of the ocean, they're hotspots for bizarre creatures found nowhere else in the world. Your next stop is just off the coast of Cuba. Circular columns, paved floors, symmetrical stone structures. That's what the Cuban underwater city looks like. What happened there? Why was a large city abandoned at a depth of more than 2,000 feet? Lots of people believe those are the ruins of a long-forgotten civilization. But scientists have their doubts. They claim the lost city is nothing but a natural phenomenon that appeared about 5 million years ago. The disc and donut structures often appear around the areas of the seafloor where natural gases break free. Again with the gases. When you come to visit the Sargasso Sea in the middle of the North Atlantic Ocean, you won't find its shores. Instead, it's surrounded by powerful ocean currents. These are the same currents that turn the sea into a gigantic convention for dense brown seaweed. In the 19th century, a French ship was discovered in the Sargasso Sea. Its sails were set, but not a single crew member was on board. This mysterious disappearance made people believe the seaweed was carnivorous. The Sargasso Sea is indeed a weird place. It's always eerily calm and unnaturally warm, even though it's surrounded by the churning, freezing waters of the Atlantic Ocean. Could one of these bizarre places become a home to the largest marine predator ever, the Megalodon? The giant shark's teeth, some larger than an adult man's hand, have been found pretty much all over the world. But since these creatures preferred warm, shallow waters, they lived along the coastlines of all continents except Antarctica. In other words, it'd be a waste of time to search for the giant predator in the depths of the Mariana Trench, in Greenland, or in Mexican cenotes. But then, could it choose the waters of the Caribbean to hide from the hustle and bustle of the modern world? Don't get your hopes up. There's been no proof the Megalodon does exist these days. It wasn't a shy, elusive animal, and still, no one has seen this shark lurking around recently. Not even near the fart spas.
The Mariana Trench in the western Pacific Ocean is the deepest place on our planet. If you throw a rock into the water, it'll travel 36,000 feet before touching the bottom. But unlike your body, the rock won't experience any unpleasant consequences. After all, it doesn't get affected by all that immense pressure that builds up the deeper you go. But then, what would happen to your body at the very bottom of the Mariana Trench? Put on your flippers. It's time to dive. Hold your breath. You're 5 feet below the surface, and it's still pretty comfortable down there. You're used to this depth. You go that deep when diving in the pool, or maybe at the beach when watching exotic fish swimming near the bottom. But you're serious about reaching the deepest point of the Mariana Trench, the Challenger Deep. So you keep going. 32 feet. That's where you start to feel some discomfort. Here, the pressure pushing down on your body has doubled. Your ears and lungs feel a little sore. This is because people have many air pockets in their bodies. And under pressure, these pockets shrink in volume, and you can feel it. But don't worry, your organs aren't made of metal. They're flexible enough to withstand even more pressure than that. What you should worry about at this depth is the white shark. If it wants you for dinner, you're in worse trouble than high pressure. That's why you'd better keep diving. Around 65 feet underwater. That's where you'll need a flashlight and air tanks as you're running out of breath. The sun's rays barely reach here, and it's pretty dark. For the same reason, you're getting cold. How about putting on a thermal suit, which is what divers usually wear? It's better now. But even though you feel warmer, your ears are starting to hurt a lot. And your lungs have shrunk almost 3 times their normal size. This can be risky for an untrained diver. But you're brave enough, and now you're already at a depth of 100 feet. Only professional divers go that deep without special equipment. The pressure here is 3 times higher than what you experience on the surface. something weird starts happening to your body. It's not like anything you've ever felt before. And the reason is your air tank. The compressed air inside is mostly nitrogen, 78%, and oxygen, around 21%. But that deep down, nitrogen becomes kinda toxic. It can make you do strange things, like you may forget you're underwater and pull off your oxygen mask. But if you take tanks with more oxygen in them, the dizziness and other strange sensations will pass. 200 feet below the surface, the pressure here is 7 times higher than on dry land. Now, even the oxygen becomes unsafe to you. You have to breathe some gas with helium in it. A sharp drop to a depth of 700 feet. This mark is the world record in free diving. Herbert Nitsch once managed to reach that deep without any special equipment or air tanks. After that, he received the title of the deepest man on Earth. In 2012, he tried to break his own record and plunged to a depth of 830 feet. But it didn't end well for his health. Anyway, if you trained to hold your breath for that long, you would probably have very few problems now. That deep down, you need to start looking around again because there can be heavy traffic. Submarines travel at this depth, and you sure don't want to collide with one of them. A few more feet deeper, and you've reached the limits of the average human's body. At the same time, laboratory experiments have proven that people can withstand even higher pressure. It went like this. A diver entered a special chamber the size of a room. Scientists simulated high pressure, comparable to a deep dive, inside this chamber. This way, the researchers discovered that a trained person can withstand the pressure similar to that at a depth of 1,600 feet. But the diver couldn't just walk out of the chamber after the experiment was over. At high pressure, nitrogen, helium, and other gases build up in the body. And if you normalize the pressure at once, those gases form into bubbles. The consequences are extremely unpleasant, to say the least. So, you have to do a gradual ascent from this depth. This way, the gases can leave your body in a natural way. Sometimes a dive takes a few minutes, but coming to the surface stretches for many hours. It's all about safety. Okay, now you have to put on a special suit. Otherwise, you won't be able to dive any deeper. It can protect you at a depth of up to 2,300 feet. The suit's sealed, and the pressure inside is exactly the same as on the surface. But all too soon, the suit's protection isn't enough anymore. You need a new means to continue your descent. And that's the Triton 6600 submarine. Now that you're sitting inside a large iron machine, you feel as if you're driving a car. Only this vehicle is worth $5.5 million. You certainly don't want to smash it, so be careful. You've reached a depth of 6,600 feet. Don't even think about getting out of the submarine. The pressure here is 200 times greater than on the surface. Your body just won't survive this experience. There's still almost 30,000 feet to the bottom of the Mariana Trench. If you teleported right there, a huge column of water nearly 7 miles high would press down on you with all its force. Your sightseeing tour would be over before it began. Even pressurized submarines can't withstand that kind of force. Large metal machines just burst like air balloons. At the moment, people only explore the bottom of the Mariana Trench with the help of robots and drones. One such machine is Nereus. This is an autonomous underwater vehicle that was built specifically for deep-sea diving. It can withstand pressures 1,000 times greater than those on the surface and reach a depth of nearly 36,000 feet. In May 2009, Nereus got to the bottom of the Challenger Deep, the deepest known point on our planet. Thanks to this machine and its 2 cameras, people could watch what was going on at that enormous depth. But people have also set foot in the Challenger Deep. Back in 1960, the Trieste bath escape descended to its bottom. The vessel was carrying 2 crew members. Unfortunately, they couldn't see their surroundings well. There was only one small window in the bath escape. It helped the structure of the ship remain strong. Plus, to withstand the incredible pressure, the iron walls of the bath escape were 5 inches thick. But when the explorers reached the ocean floor in the Challenger Deep, one of the window's panes did crack. Luckily, the ship was still able to spend about 20 minutes at the bottom of the ocean and then rise to the surface. But there are living creatures that are used to such incredible conditions. The Mariana snailfish, for example, lives at a depth of 24,000 feet. Even the bottom of the Mariana Trench is inhabited. Bacteria and viruses live there. They're used to low temperatures and high pressure. And their food is all kinds of organic matter that sinks to the bottom of the ocean. People can also survive in other extreme conditions, for example, in space. It's a vacuum. Unlike what many people believe, it's not cold. It's also not as dense as air or water. That's why you'd lose your body heat very slowly. But you can do an experiment. Normally, water boils at 212 degrees Fahrenheit. Let's say you place a glass of water in a special chamber and gradually lower the pressure. The lower it is, the lower temperature the water needs to boil. You're 70% water. And since space is an almost absolute vacuum, the pressure there is extremely low, near zero. And now, think about what can happen with your very liquid blood. I believe you can imagine the consequences. Ouch. Also, your internal organs would begin to expand. But that's not a problem. Your tissues are flexible and can withstand such an experience. The main issue would be the lack of oxygen. Without air, you'd soon lose consciousness. And still, if the rescue team could get to you within 1 to 2 minutes, you'd be fine. But there are living organisms that can survive even there. One bacterial species was thriving in outer space near the International Space Station for 3 years. These bacteria don't mind the vacuum and the lack of oxygen. They've even managed to survive strong solar radiation. They rightfully deserve the title of the world's most resistant bacteria.
You know how they say it's better to just hand over your wallet if you run into a mugger? Instead of surrendering their wallets, sea cucumbers choose to spit out some of their insides to fend off predators like crabs and fish. It's a natural defense mechanism for them, and they quickly grow those organs back in just a few days, thanks to special cells inside their bodies. It's not the only weird thing sea cucumbers do. They can actually breathe through their rear end. They have this thing called a respiratory tree that connects to their backside and sits right next to their intestines. So when they suck in water from their behind, it goes into that respiratory tree, letting them absorb oxygen directly into their fluids. Plus, sea cucumbers are the janitors of the ocean. They munch on whatever gets stuck in the sand on the ocean floor. Once they've eaten, they manage to clean out the sand, leaving it nice and tidy after they do their business. As for the clean sand, the stunning white sand beaches in Hawaii are actually a product of parrotfish number 2. These fish munch on algae from rocks and dead corals, and while they're chomping away, they also grind up the leftover bits of coral in their bellies. When they're done, they move their bowels, and voila! It all comes out as beautiful sand. Not only do they play a vital role in keeping the coral reef ecosystem healthy, but they can churn out hundreds of pounds of this white sand every year. Marine animals are seriously impressive when it comes to holding their breath. Just look at sperm whales and elephant seals. They can stay underwater for a mind-blowing 2 hours. Then there's a Cuvier's beaked whale, which holds the crazy record at almost 4 hours underwater. When you compare that to the human record of 24 minutes and 37 seconds held by pro diver Budimir Shobat, it seems pretty insignificant. But what's the marine animal's secret that helps them excel humans this much? Unlike us, these sea creatures have a ton of hemoglobin and myoglobin in their blood and muscles, allowing them to store way more oxygen. When their oxygen runs low, myoglobin steps up and releases even more. Plus, they can tolerate higher levels of CO2, so they don't feel the need to breathe as quickly. There's even a study that found their myoglobin molecules have a unique charge that keeps them from sticking together, which boosts oxygen storage. And on top of all that, they can slow down their heart rate and restrict blood flow to hang out underwater even longer. Rumor has it that about 540 million years ago, a meteor loaded with frozen octopus eggs smashed into Earth. Sounds like a delirium, but some scientists are entertaining a very questionable idea that octopuses and their cephalopod buddies, like squids and cuttlefish, might actually have some extraterrestrial origins. The thing is, cephalopods have extraordinary DNA that doesn't look like any other DNA on our planet. They've got around 33,000 protein-coding genes in their genome, which is way more than what we humans have. A recent study suggests that their evolutionary story shows some odd traits that might hint at a connection to space, like they could be from some super far-off past, or even the future. The researchers went as far as to claim that modern octopuses could be the descendants of these frozen creatures that hitched a ride on comets and splashed down in our oceans. And why octopuses? Well, they really stand out in the animal kingdom. They can use different tools to build their own houses, and they can even solve everyday problems independently of their brain, as 2/3 of an octopus's neurons are in its arms. These traits seem to have just appeared out of nowhere during evolution. They even tossed around another quirky theory. What if an extraterrestrial virus crashed into early squid populations and gave them a crazy boost in evolution, turning them into the octopuses we know today? Anyways, these are just fun speculations without any hard proof. Now, this funky object is an animal, not a rock. It's called sand dollar. Just look at the shape of its shell. Once sand dollars are exposed to the sun, their shells lose their soft, spiny covering and become bleached white. Back in the day, beachcombers thought these shells looked a lot like big silver coins, kind of like the old Spanish dollar that was about the same size. But if you prefer, you can call them sand cakes instead. These quirky creatures have tiny spines on their surface, and they glide along the ocean floor. They use small tube feet that line the grooves on their underside to grab bits of food like plankton and algae, which they then send to their mouths. Inside, they have 5 triangular teeth that help them munch on their meals. In some Georgia folklore, sand dollars are said to represent coins lost by mermaids. Sand dollars have a unique talent for cloning themselves. They can do this for a bunch of reasons, like when a predator comes around. Some species of sand dollar larvae can actually split in half as a defense mechanism. It takes about 24 hours for them to clone themselves, and the new larvae end up being about 2/3 smaller than the original, which helps them hide from danger. Wait, is that a giant sea hot dog racing through the ocean? Sorta. Some scientists have joked that sperm whales seriously resemble enormous hot dogs. These massive creatures can take quick naps, standing up for about 10 to 15 minutes. They only sleep about 7% of the time, mostly between 6 p.m. and midnight. Sperm whales also have a cool ability to retract and extend their eyes, thanks to a thick retractor muscle around them, but they can't actually roll their eyes in their sockets. Plus, they have the most asymmetrical skull of any mammal out there. Oh, and let's not forget, they have the largest brain of any living creature, weighing in at over 9 pounds. Unlike us humans, if dolphins went into full-on snooze, they'd stop breathing and could drown. So they figured out a genius solution. They let only one side of their brain sleep at a time. This means one half stays awake to keep them breathing and watching out for any potential threats. When they snooze, they only close one eye. If their right brain is resting, their left eye is shut, and vice versa. This unique sleep style is called unihemispheric sleep, and it lets them recharge without ever fully losing awareness. On top of that, dolphins might be using corals and sponges like their own little pharmacies. Scientists have seen them rubbing their bodies against specific types of coral and sponges, suggesting they might be treating skin issues. They've even spotted dolphins lining up to take turns at these spots, using corals like Gorgonian coral Rumphella aggregata, leather coral, and some sponges. What's really fascinating is that researchers have analyzed these corals and found they contain compounds that could help with dolphin skin conditions, which can sometimes lead to infections and lesions. Now, the big question is figuring out exactly how each type of coral helps dolphins, and if it really boosts their health overall. Sea urchins aren't exactly the Usain Bolts of the ocean. They move slowly by crawling with their tube feet and occasionally give themselves a little push with their spines. These little guys have just 5 teeth, which they use like a beak to scrape algae off rocks, which I'm pretty sure is the ocean's version of an all-you-can-eat buffet. But since all that scraping wears their teeth down, they're in a never-ending dental replacement program. Scallops are the underwater equivalent of the world's most confused security cameras, sporting up to 200 tiny eyes on their shells. These eyes are high-tech. They can even adjust their pupils to light. Instead of working like ours, scallop eyes have a unique setup. Light goes through a pupil, lens, 2 retinas, and then hits a mirror made of guanine crystals that reflects it back. Scientists were puzzled about how they see since their main retina often gets blurry light. But it turns out, scallops can change their pupil size by about 50%. Just don't expect them to do it in a hurry, as it takes a few minutes.
Now here's something really neat about orcas. They're expert hunters, and they do it in groups called pods. A pod can consist of up to 40 orcas, forming a very effective hunting team. Interestingly, there are distinct types of pods: resident and transient. Resident pods are more into fish, while transient pods have a taste for marine mammals. But no matter what type of pod they belong to, all orcas have one thing in common: they are master collaborators. They work together using smart hunting techniques that are often compared to the teamwork of wolf packs. Almost 95% of jellyfish's body is made of water. For comparison, the human body is 60% water. It's probably not a surprise since jellyfish don't have a heart, blood, eyes, or brain. The other 5% of their body weight is proteins, muscles, and nerve cells. Jellyfish have been around for more than 500 million years. This makes them older than dinosaurs. These creatures haven't changed much, and today's jellyfish are pretty much like their ancestors. Electric eels have small eyes that are not so effective in environments with no light, so they mostly rely on their electric organs. Those consist of 6,000 cells. Eels use them to stow power, similar to batteries. These creatures use electricity like bats use their radars or dolphins their sonar. An eel can also produce enough electricity to power a panel of light bulbs. There's a small tropical archer fish that can learn to recognize human faces. This fish has an interesting ability to spit small jets of water from its mouth. Researchers showed the fish the image of 2 different faces placed side by side. One was unknown and the other was familiar. The fish was supposed to spit water at the familiar one. The creature took the right guess more than 80% of the time. There's such a thing as a sea unicorn. That's an animal called the narwhal. Its horn is actually a tooth that can grow up to 10 feet long. Manatees, also known as sea cows, are distant relatives of elephants. Their weight can go up to 1,000 pounds. These creatures are vegetarian and need to eat around 10% of their total weight on a daily basis. That's lots of sea salad. In some cases, manatees share space with alligators, but they get along pretty well. You can even find a photo from Florida where an alligator rides a manatee's back. Frogfish have special fins that help these creatures walk along the sand. They're very useful in shallow waters. A ghost pipefish is hard to see, but once you spot it, you're bound to get really surprised. Its head makes up over 40% of its body. Crabs don't feel like wasting time on such formalities as putting foods in their mouth. That's why they taste it with their feet, which is where their taste buds are. Marine iguanas are the only lizards on our planet that like spending time in the ocean, even though they mainly live on land. They're herbivores that feed in shallow waters and swim like snakes. Iguanas use their long claws to hold on to the bottom when they need to graze. Green turtles can cross over 1,400 miles when migrating. They try to find the perfect spot to lay their eggs. Penguins sort of fly when they're underwater, reaching a speed of 25 miles per hour. More than 5 million years ago, I've heard, I wasn't around then, deep-sea worms and humans had a common ancestor. So we still share 70% of our genes with these creatures, and with sea stars, squid, and octopuses. Now, octopuses are in fact incredibly old. The oldest known fossil belongs to an animal that lived almost 300 million years ago. FYI, this is before our dinosaur buddies roamed the Earth. Wait, there's more! Octopus arms have a mind of their own. That's because 2/3 of their neurons lie in their arms, not in their heads. This means that their arms can problem-solve how to open a shellfish, while their owner is worried about other stuff entirely. Talk about ninja-level multitasking. Oh, and like other animals, such as chimpanzees and dolphins, octopuses have proven to be good at maneuvering tools, like picking up old shells and using them as a temporary home. Now, of course, the most intelligent animals on our planet are humans, according to humans. But we don't seem to give pigs enough credit. Pigs are so smart they can play video games. No, not Minecraft. But in a recent academic study, scientists had 4 pigs play a joystick game. They had to manipulate the stick so that the moving ball would hit the wall and then they would get a treat. All 4 pigs did great in the test, which was surprising even to the scientists. Now, pigeons also aced an impressive test. They were trained to differentiate a Picasso painting from a Monet one, which they had no trouble learning. Then they were able to apply this knowledge, identifying works of art they had not previously seen, meaning they really understood the difference between each painter. Poor things are always seen as a nuisance. Now, if we placed kangaroos in an animal's most amazing ability contest, they'd win. It's mainly because they break the 4-legged rule. A special species of kangaroo, the red kangaroo, uses its tail to help propel it forward. Now, visually, it has 4 limbs, but in practice, it uses 5. They're biologically built to use their tail as a 5th limb, since it's packed with articulated vertebrae and thick muscles. Of course, it had to be an Australian animal. Deep within the Sahara Desert, you'll find a little creature known as the fennec fox. This huge-eared animal adapted perfectly to survive in its hostile environment. The huge ears help them to dissipate the unbearable heat of the desert, as well as help them to hunt for underground prey. Now meet this guy. Unlike what its name might suggest, the red panda is closer to a raccoon than it is to a giant panda. You'll find a lot of these cat-sized creatures in the Himalayan region, hopping from tree to tree and bundled together trying to keep warm in the harsh weather. They're gentle and friendly like their big panda cousins, and occasionally enjoy eating some bamboo sticks. And then there are bees. Compared to humans, bees' brains are the size of pinheads, yet they are capable of astounding things. Let's say a bee is running low on energy after a long search flight. This bee desperately needs a drop of honey in order to continue flying, but smartly enough, she doesn't need to go back to the hive to recharge. She can ask a fellow beehive mate for a drop of honey directly from this other bee's stomach and continue flying. This type of decentralized system allows them to build highly effective societies, one that bees don't need to push through the queues in front of the honey cells, for example. Every year in the winter, great white sharks that live along the California coastline disappear. It feels as if they take a vacation for 30 to 40 days. The animals go to a point halfway between Hawaii and Mexico. They might do it to get some food, relax, or hang out with their buddies from other areas. The spot is now called the Whale Shark Cafe. Some types of sharks, like makos, whale sharks, or white sharks, breathe in a very specific way. It requires them to swim all the time. They also need to move quickly and with their mouth open. This way, the oxygen can enter and reach their gills. Sea sponges are some of the most primitive animals. They're immobile, don't have a mouth, eyes, bones, brain, heart, lungs, or any other organ whatsoever, and still, they're alive. There's such a thing as a sea unicorn. That's an animal called the narwhal. Its horn is actually a tooth that can grow up to 10 feet long. Manatees, also known as sea cows, are distant relatives of elephants. Their weight can go up to 1,000 pounds. These creatures are vegetarian and need to eat around 10% of their total weight on a daily basis. That's lots of sea salad. In some cases, manatees share space with alligators, but they get along pretty well. You can even find a photo from Florida where an alligator rides a manatee's back. Frogfish have special fins that help these creatures walk along the sand. They're very useful in shallow waters. A ghost pipefish is hard to see, but once you spot it, you're bound to get really surprised. Its head makes up over 40% of its body. Crabs don't feel like wasting time on such formalities as putting foods in their mouth. That's why they taste it with their feet, which is where their taste buds are. Marine iguanas are the only lizards on our planet that like spending time in the ocean, even though they mainly live on land. They're herbivores that feed in shallow waters and swim like snakes. There's something known as the orange cat behavior, and apparently it's not just a meme. So far, scientists have been able to understand that coat color is connected to a feline's gender. And since orange is an X chromosome, orange cats are usually males, like Garfield. The so-called orange cat behavior describes ginger cats as agents of chaos. Again, pretty much like Garfield. However, there haven't been any conclusive studies on whether coat color and cat behavior are truly linked. In terms of vision, mantis shrimps probably have the most psychedelic vision out of all animals. These funny-looking creatures have a whopping 16 varieties of photoreceptors, with 5 of them reserved for the ultraviolet or UV spectrum. Ultraviolet rays are really short wavelengths, which are invisible to humans. The thing science still doesn't understand is how exactly these mantis shrimp view the world around them. Sure, they can perceive a bunch of colors, but they can't necessarily distinguish all of these colors among themselves. It can be that they just see a lot of really vivid, really blurry colors, but we haven't figured out a way to check that out. Now, to say sloths are cute is an understatement. They may be one of the friendliest animals in the jungle, but there's more. If you look closely at their fur coat, you'll notice hints of green. These greeneries are actually tiny little algae that grow alongside sloths. They help sloths to camouflage better in the jungle, but they also nurture them. The little cracks inside a sloth's fur create the perfect environment for algae reproduction, and scientists have found species of algae that don't exist anywhere else in the world. They do get by with a little help from their friends. Deep within the Sahara Desert, you'll find a little creature known as the fennec fox. This huge-eared animal adapted perfectly to survive in its hostile environment. The huge ears help them to dissipate the unbearable heat of the desert, as well as help them to hunt for underground prey.
Most of the ocean is still shrouded in mystery, whether we're talking about dark corners or creatures that are hiding in the depths. But sometimes, it gives us a peek into scary things it hides in its cold, dark depths. Like when you hear on the news that there are some deep-sea creatures washed ashore after a powerful storm once again. Some just look weird, while others are real monsters that live at depths of more than 3,300 feet. The coldest and deepest parts of the ocean have created one specific phenomenon called gigantism. So, sea spiders, squids, worms, and many other animals, mostly invertebrates, or creatures without backbones, they're all way bigger and scarier than the versions we see in the more shallow areas. In the Pacific depths, you can see a sea sponge as large as a minivan. Or what about the colossal squid that lives in sub-Antarctic waters and is nearly 14 times longer than the arrow squid, a type that mostly lives in New Zealand? Researchers found many of these underwater monsters in the abyssal zone of the ocean. Back in 2021, the researchers showed images of the giant phantom jelly. It was at a depth of 3,200 feet. Its tentacles were 33 feet long. Wow, I wouldn't like to face that one on the beach. It probably eats only small fish and plankton, but it can swim to depths of more than 21,900 feet. And down there, this giant jelly doesn't have enough food. How does it survive then? Scientists haven't figured it out yet. And there are even more questions related to the giant squid, the biggest one ever found. This monster is 43 feet long, with a weight of nearly a ton. Imagine if those tentacles would grab your car, or something like that. They would smash it like it was a toy. There's no light in the abyssal zone. Sun rays just can't penetrate that deep. So there's no algae or underwater plants there. Local animals mostly eat snow. Marine snow is not like the regular one you build a snowman with. It consists of any small flakes or remains that fall from the surface of the ocean. Maybe even some leftovers that animals up there couldn't eat. So it's not much, but apparently it's enough for very large creatures that hide deep down there, like giant squids. Squids that generally live at such depths don't bother going after their prey. They just wait until the poor animal swims right up to their long tentacles and falls into a trap. It may not be the best method ever, because not many animals will even swim into these dark, cold parts, but it's the method that saves energy. A giant squid eats only 1 ounce of fish daily, which is approximately 45 calories. That's nearly 50 times fewer calories than an average person should eat per day. So when a squid gets 1 fish, it saves it for a couple of days. I hope giant squids won't get the idea to go to the surface and look for food when there's not enough of it in the abyssal zone. And I hope even more that giant Greenland sharks won't get that same idea. You can find them at depths of up to 7,200 feet. They're twice as slow as we usually walk. They swim at a speed of 1.12 feet per second. Their slowness is part of the energy-saving mechanism that creatures down there need to survive. But they can speed up in the form of short bursts when they need to catch prey. But they kinda change their diet from predator to scavenger, considering their environment. There will be more leftovers falling from the surface than animals to go after. Greenland sharks grow just 0.4 inches per year, and they're mostly 20 feet long, which means they live for a very long time, sometimes up to 400 years. They also have a slow metabolism, and that's one of the main factors for their long life, too. Greenland sharks like to spend their time in cold waters. They're adapted to that, since their tissues have specific chemical compounds that prevent the forming of ice crystals all over their body. That means they have some sort of natural antifreeze. So what makes them so big? Scientists are still not sure, but some theories try to explain it. There's this thing called Kleiber's rule that says bigger animals tend to be more efficient. Just take a small fish and compare it to a whale with a mass hundreds of times bigger. The whale has a greater metabolism. It conserves energy more efficiently and loses less of it to the surroundings through heat. Moving on, bigger animals can ingest bigger prey. They're more likely to go through tough issues in their environment or defend themselves from predators going after them. Also, the body gets bigger when temperatures are lower. The Greenland shark is a perfect example. So are giant sea spiders. Sea spiders are generally common, and you find some very small ones at 0.04 inches. But in deeper parts of the Antarctic, they become 3-foot-long giants. They grow so big because the cold water has more oxygen. That way, more of it diffuses into the animal's body, and that allows it to grow bigger. Yeah, both as a creature and a nightmare. And how about this giant tube worm? Researchers found it accidentally while they were exploring the mysteries of the Pacific Ocean floor. They stumbled upon unusual hydrothermal vents. Volcanic heat is a thing that gets them going. As water seeps down through faults or cracks in the rock, these vents change their direction. When the water gets out of the vent, it's rich in different minerals and chemicals. Most animals wouldn't survive being around this toxic soup of chemicals, but not these tube worms. They came as a true surprise, because not only are they not bothered by these toxic vents and the almost boiling temperature of the water, but they developed entire ecosystems there. They're unique because they don't need sunlight to survive. Instead, small bacteria are their main source of energy. That bacteria gets their energy directly from these toxic chemicals. So it's not photosynthesis, but a process called chemosynthesis. And these tube worms don't have mouths. These bacteria live inside them. Strange story, huh? Plus, these scary worms reach up to 8 feet. Giant isopods are no better either. They lurk at the depths of the ocean of 1,640 feet or more below, far away from the sunlight, looking like some monstrous wood lice. They spend most of their time on the seabed, hoping to find some food falling from higher levels of the ocean. Check out their small hooked claws at the ends of their legs. Isopods use them to remain more stable while moving around the ocean floor. Since there's no light, they have long antennae that help them feel their way around. These sensory antennas are about half the length of their body. Giant isopods have pretty big eyes compared to their body size too. They can grow over 12 inches from head to tail. And these fellas are really patient. Remember how we said animals down there rarely get food? Sometimes they need to wait for years to get a proper meal. That's why their metabolism is amazingly slow.
5 years later.
They can go for 5 years without eating anything. Imagine that. I get hungry just talking about this. In 2006, a biologist did research to compare the differences between the shallows and the deep sea regions. He realized the deep sea mirrors the island rule. First, isolated parts of land develop biodiversity you won't find anywhere else. Second, small-bodied life there grows much bigger when it's isolated, compared to life on large land masses. Resources are limited, but also competition and predators. And we don't know much about these deep-sea creatures. It's too expensive and too complicated to carry out such research, so we'll just wait for more raging storms to show us at least part of the monstrous world cold ocean depths hide. If you could dive right into the mysterious darkness of the ocean depths, who knows what you'd come upon? Legends that are hundreds of years old mention some giant sea monsters hiding deep down below the ocean waves, like the Kraken, the Loch Ness Monster, the Hydra, Leviathan, and so many more. Okay, no one has ever seen such monsters, but there are still weird and unusually big sea spiders, squid, worms, and many other animals that grew way more than we'd expected. Take a look at the colossal squid from sub-Antarctic waters. It's around 14 times longer than the arrow squid that lives near New Zealand. And deep down in the Pacific Ocean, there's a sea sponge as big as a minivan. Oceans contain about 96.5% of all water on our planet. Up to 80% of all life on Earth we've discovered is under the oceanic waves. We haven't explored, mapped, or even seen more than 80% of the ocean. In fact, we've mapped Mars better than we have the ocean bottom. The pressure down there is insane, and it would make you feel like you're holding up almost 50 jumbo jets. And temperatures at such depths are extremely low. Conditions deep below the oceanic surface are harsh, so creatures that live there need to adjust. That's why many of them grew very, very big to survive. Creatures that live in cold, dark depths are so big because of a phenomenon called deep sea gigantism. The deeper you go below the oceanic surface, the less sunlight there is. That's why the temperatures drastically fall. The result of this is increased cell size and longer life of creatures. Also, these creatures don't have as much oxygen as the marine animals that live in shallower parts, and their food sources are minimal. Much of the food they get comes from shallower waters, and only a little bit trickles down to the deeper parts. And when there's not enough food, being large is an advantage. Larger creatures can move farther and faster to find something to eat. Their metabolism works slower. They don't digest the food that fast, so they can store food and conserve energy for hard times when they can't find anything to eat. They don't need to regulate their body temperature either, which also helps them save some energy, which they can then transfer to other body processes. They mature more slowly and later than those living in shallow waters. The majority of fish species that dwell in deep waters live 30 years or even more. Orange ruffy fish, on the other hand, live up to 150 years. This fella grows 24 feet in length and weighs up to 1.5 tons. But it grows to be so big for centuries. They start looking for partners when they're 150 years old, and they can also live this long because there are not so many predators at such depths. Also, there are no humans or other things that can disturb them or endanger their existence. At such depths, the environment is pretty stable, so many animals there are like living fossils, because they probably haven't changed in millions of years. The first 650 feet of the ocean's depth are considered to be the open ocean. The majority of the marine life we've discovered lives there, since that's the area the sun can still reach. And then, as you continue going deeper, you reach the twilight zone. It seems like nothing lives there. But at about 820 feet, you see a small oasis of ancient life blooming. For example, there are sea lilies, animals that have been living at such depths unchanged for millions of years. Coelacanths, another living fossil, have been living in the ocean for more than 360 million years. Hagfish haven't changed in a very long time either, for over 300 million years. This creature lives at depths of 5,500 feet. They evolved before the rest of the vertebrates, which is why this is the only living animal without jaws or a spine, even though it still has a skull. Deep-sea creatures can't survive in shallow waters. They've evolved to live in depths under bigger hydrostatic pressure. Humans and other organisms that have internal spaces filled with gas would end up crushed if we could go to such depths. That's why deep-sea divers always need to wear special dive suits designed for surroundings with higher pressure, even though they're not going that deep to the areas where these giants live. But near Antarctica, you can see gigantism way closer to the surface, like giant sponges, sea slugs, sea spiders the size of a dinner plate, worms, and even some enormous single-celled organisms. They all tend to chill in shallower waters. Scientists are not sure why exactly, but they think it could have something to do with oxygen. Giant species use just a little oxygen, and the waters around Antarctica are pretty rich in it, which means there's hardly any limit to these animals growing bigger and bigger. Back to deep-sea creatures. As mentioned, they had to adjust to strong pressure, so they almost don't have any air gaps in their body at all. They're mostly water-based, and since water is incompressible, which means it's not something you can compress, it helps them stay unaffected at such high pressure. But because of all that, if they were to go up towards the surface, they'd probably swell up, maybe even explode. Just look at the blobfish, the one that takes the title of the ugliest animal in the world. It looks normal deep down below the surface, where its natural habitat is. But when it gets up to the surface, where the pressure is 120 times lower, it changes its shape. The blobfish doesn't have a skeleton or muscles, so without high deep-sea pressure, it ends up being all floppy and saggy. The dark oceanic depths are not just scary to watch, but to listen to as well. In 1997, scientists were trying to find underwater volcanoes located off the South American coast. During their travels, they recorded one of the loudest noises ever registered. It was pretty weird, too. It was so loud, even sensors from more than 3,000 miles away managed to pick it up. They later called it the bloop. It took them 15 years to conclude the sound came from an ice quake. That's when seismic activity breaks frozen ground. Water at the bottom of the ocean is not always extremely cold. There are hydrothermal vents on the seafloor, and the water that comes out of them can be up to 750 degrees Fahrenheit. Powerful pressure, yep, the same one that would crush you, is something that doesn't allow the water to boil. There are hundreds of animal species that live near deep-sea hydrothermal vents. Some of them, such as tube worms, are not like anything we have seen before. These worms absorb chemicals from vent fluids. That's how they feed bacteria that live in them. And in return, those bacteria give them the carbon the tube worms need to survive. 2/3 of all of the coral species scientists discovered live in dark, deep, and extremely cold parts of the ocean. Some even live in parts that are 3 miles deep. They can survive at low temperatures, such as 28 degrees Fahrenheit. Some of these cold water corals are more than 8,000 years old. They form amazing structures that can rise up to 115 feet tall. The deep is not just a mysterious world of unusual creatures. The landscape under the oceanic surface is magnificent too. The canyons hiding there make even the Grand Canyon seem small. For instance, check out the one located in the Bering Sea, the Jemchug Canyon. Its vertical relief is more than 8,500 feet deep. That's huge. The largest ocean waves are not the ones you can see from the shoreline. They occur under the surface, and they're called internal waves. They take place between two water masses that have different densities. They travel at speeds of thousands of miles per hour and can be 650 feet tall.
450 million years ago, no, I wasn't around then, the sea level was higher, coral reefs started to form, the climate on our planet was stable and warm, not even dinosaurs were around yet. The time when bony and jawed fish we know as sharks appeared. They've been dominating the oceans and making other marine creatures flee in fear ever since. Many of them, like great white sharks, have evolved and adjusted to life in the open ocean as hunters with a pretty high position in the food chain. They're less diverse today than before. One of the reasons is the asteroid strike from the age of dinosaurs. After it reduced the number of shark species, only smaller and deep-water kinds that ate primarily fish survived. They started getting bigger over time. Near the surface, sharks such as makos or great white ones develop faster movements and are somewhat between gray and blue to blend in with their surroundings. The epaulet shark can even walk on the land. It can't take a walk on the beach because it can't breathe outside of the water, but it lives on coral flats in shallow tropical waters, so it can walk in kind of a crawling motion. But deep down below, there are mysterious, alien-looking, often huge shark species that didn't come to the surface, which is why they didn't need to adjust to the new environment and different conditions. They haven't changed a lot through time, so they're some living fossils. These creatures mostly don't have 5 gill slits, the most common number, but 6 or 7. It's because there's less oxygen the deeper you go in the ocean, so they need more gill slits. Sharks on the surface evolved to have fewer gill slits. 6-gill sharks are the most primitive sharks we have today. Their skeletons are like those of ancient extinct sharks, and they can survive only in very deep waters. Like cats, sharks have a layer of reflective cells placed inside their eyes, which helps them see better in the dark, deep sea or cloudy waters. Sharks on the surface have big eyes because they evolved to hunt in the sunlight, so they tend to rely on their vision. Those that live in shallow waters have small eyes, so they can protect themselves from the sand. Like some other deep-sea creatures, 6-gill sharks also have bigger eyes to take in as much light as possible. They have more light-sensing rods, but don't distinguish colors that well. In the ocean's twilight zone, with the minimum of sunlight, there's a couple of bioluminescent shark species. They don't take in light within their eyes, but produce or re-emit it with their bodies. Their skin or organs have specialized cells that produce a soft blue-green light. Deep-sea creatures that produce their own light do that to attract their prey, deter animals from going after them, or, scientists think, communicate with each other. It can even help them to camouflage. They do it by hiding their silhouettes from animals going after them. They produce enough light to match their surroundings. The biggest luminous underwater creature is the kitefin shark, found swimming 980 feet below sea level, preying on groundfish or smaller sharks. It can grow almost 6 feet long and lives 3,200 feet below sea level. Deep-sea sharks are also bigger than those on the surface. The Greenland shark can grow up to 24 feet long, bigger than a great white. There's a thing called deep-sea gigantism. Creatures in nutrient-poor depths of the ocean grow bigger because, that way, they lose less energy as heat. The Greenland shark lives its life in slow motion. It has a slow metabolism and can go very long periods without food. With their slow pace, they evolved to live up to 500 years at depths of 7,200 feet. Sharks in shallow waters catch their prey relying on agility and speed, but for them, it's easier because there's plenty of food on the surface. Deep-sea sharks, with less food and slower life rhythm, had to develop a different style. They're more opportunistic, definitely not picky, and don't care if their future meal is alive or not. Frilled shark, Another living fossil from the darkest depths hasn't evolved much through time, and they're one of the last of their kind, with all of their relatives already gone extinct. It grows up to 7 feet long, primarily hunts on squid, and catches other sharks and fish. It looks like a dinosaur, a snake-like face, a long, smooth, thin body that moves in a serpentine way. It can propel itself with the power of its tail and curl like snakes. They don't swim in a straight line like other sharks. Cookie cutter shark grows up to 20 inches. It got the name because of the way it feeds, biting off small pieces. It's a parasite creature, which means it feeds off bigger animals but leaves them alive. They have sharp teeth and sometimes even swallow those that fall off on purpose. Some researchers think it could be because they live in the depths that are nutrient poor. If they swallow the teeth, they could recycle calcium and other material from it. Prickly shark is a rare and unusual creature with many thorn-like denticles and 2 small dorsal fins. It lives mostly in the depths of the Pacific region up to 1,900 feet. Ghost sharks are not even real sharks, but fish closely related to them and rays. They have big pectoral and pelvic fins, 2 dorsal fins, pretty big eyes, and unlike their cousins, have a single external gill opening. Ghost sharks have slender tails and can grow up to 80 inches, silver to blackish color. They sometimes live in rivers and coastal waters, but also in the depths of the ocean of 8,200 feet or even deeper. They are pretty weak swimmers, so they tend to feed on invertebrates and small fish. Goblin sharks. Swimming through the deep sea, this creepy shark with a flabby body suddenly sees a small, innocent squid. It goes toward it, but the potential snack notices it and quickly starts moving to dart away. It seems like the plan could work at first, but then the shark suddenly thrusts the jaw of its mouth and catches the poor little squid in a second. After the meal is finished, the animal simply fits the jaw back into the mouth and goes away as if nothing happened. This is possible because it has a jaw connected to 3-inch-long flaps of skin, which is why it can unfold from the snout. It can grow up to 12 feet long with a weight of 460 pounds. Scientists think goblin sharks are mostly active in the morning and evening. The shark has a long, prominent snout and specific sensing organs on it. It uses them to sense electrical fields in the dark oceanic depths. Seven-gill shark is a big cow shark, brown to silver-gray on top, white underneath, black and white spots, with a thick body, a small dorsal fin, and a wide, blunt snout. It can grow up to 10 feet long, mostly lives in the depth of 1,870 feet, but you can also find it in deep channels and bays. It can be aggressive toward humans if provoked, so don't. Like most deep-sea creatures, it's an opportunistic hunter that's not quite picky but likes to go after dolphins, seals, porpoises, and other marine animals. Megamouth sharks mostly live in the depths of 15,000 feet and spend most of their time in the dark, like me. Scientists discovered it in 1976 because it went near the surface at night to feed on zooplankton. That's the only time these sharks go there. During the day, they return to their quiet, dark, and mysterious depths. They are filter feeders, which means they keep their mouths wide open while swimming, so they filter the planktons they like to eat. There are organs that produce light inside of their mouths, which attracts potential prey, such as pelagic crustaceans. These sharks live in the deep parts of the ocean, but you can rarely find them below almost 2 miles. Scientists think some other, stronger bony fishes outcompeted them. Deep parts of oceans became oxygenated around 70 million years ago, and sharks have been around way longer. But bony fishes adjusted and adapted efficient ways to use oxygen, while sharks were slow with adaptations, so they lost. Also, oceanic depths are way colder, which is challenging for fish and the rest of cold-blooded animals because the speed of their metabolism widely depends upon the external temperature.